We're almost at the end of the visual wake words application. I'm going to wrap up this video and this series by focusing on the metrics that really matter. Looking at the end-to-end pipeline, we've come a long way from collecting data to designing the model to understanding how to train or cut down the training time. And now to evaluating the model. When it comes to evaluation of the model, there are quantitative measures and then there are qualitative measures. Both have pros and cons. Let's try to understand what this really means. From quantitative measures, we have things like accuracy. How well does the model do in its classification? There are also metrics that actually matter that are outside the model, which is what's the overall latency of the application, what's the amount, does the entire application with the model fit inside the resource constraints? Then, of course, there are qualitative aspects and about how well the overall application does for the end user. We've touched on these in the context of keyword spotting, and here I'm going to highlight things that are specific to visual wake words models. Talking about accuracy, I want to touch on the metrics that we have. Often we use what is called a top one accuracy. Top one actually means that the exact softmax classification score that you get has got to have the highest probability so that it matches what the original ground truth is. And in this case, it is Firefox. So that's great. Occasionally, you'll hear about what's called top five. That simply says that if Firefox shows up, anywhere in the top 5 probabilities, then that is also a completely acceptable answer. It depends on what you're looking at. Often we use top 1 as the baseline, so keep that in mind. Sometimes you hear top 5, and that's the only reason I'm bringing up, that notion over here. Now, one of the key things that is important is that you've got to think about what data you have in order to determine whether you're actually going to get, good accuracy. Because if you don't have data that is representative of the classes of interest, you have data that's irrelevant, then your accuracy is going to be bad. So no matter what your efficiency is, it does not matter because the end user experience is going to be terrible. Another thing that you could do, obviously, is trade-off accuracy for latency, which we've talked about previously when you looked at designing the model. For example, I can have a really accurate model that is also really slow. How will that work? So, well, if you look at it purely from an accuracy standpoint, it might take a fantastic choice because it gives you the highest accuracy in detecting people or something to that effect. But it takes 10 seconds to be able to make a classification and tell you, yes, there's a person in front of the camera. Is that any good? Well, will you be able to deploy that on a smart device, for instance? No, you won't be able to. So this means that your user experience is going to be terrible. So that's not really going to work. But you might be able to compromise the model quality a bit and get a faster model, which is exactly what mobile nets did. That reduced the complexity of the model through depth-wise separable convolutions, which we talked about, in order to improve the overall performance of the model and thereby give you an improved user experience. Another thing that we can do, depending on the use cases, is if you want a high quality model, then sometimes you might have to offload to the cloud. Yeah, it's the opposite of what we talked about before. If you're dealing with applications like reading a CT scan in a medical situation, the end user might be willing to tolerate long latency as long as the model is accurate. So it really depends on the application you're building and deploying. And that's the message I'm trying to get across over here. Now, last but not least, fairness. Diversity in the data is extremely important because if you build a model and it's got to work across diverse situations in which it's going to be exercised. Specifically, if the particular group that you're looking for is actually the majority group of your training data, well, you are naturally going to get a good accuracy and everything's going to work fine. In other words, if I'm building visual wake words model that recognizes my skin tone, that's great. Okay, well, I'm in the majority of the training data, so the model is going to work well. But what happens if there's a certain skin tone which the network has not seen in training? Someone who's got a much lighter color face or who's got a much darker color skin tone. In that case, if there's something very specific about the skin tone, for instance, that's getting encoded into the network, that's going to be proved really problematic because even if the model runs really well, the overall user experience is going to be bad because it's not generalizing to the characteristics that we need. So the point I'm trying to get across here is that we need to think about the diverse set of metrics. We need to identify metrics that are important, carefully. And just the way we identify requirements for a data set carefully, we need to identify all the right metrics and then work through that process. So through this last step, and even though it is the last step, it's actually greatly influences how the entire pipeline is kind of engineered. And with that said, I hope you learned a couple of things in the TinyML wake words application. We're going to be moving forward to yet another interesting application area where we're going to learn new fundamentals as we go through the same process of dealing with sensors and then the network, and then how we are going to be able to actually evaluate that particular scenario. So stay tuned for that.